All right, so this is our last day of reviewing just graphing a line. I've just thrown them in a different form. Maybe in Algebra 1 you learned how to graph in point slope form or standard form. I'm going to show you those strategies. If you hate them, just turn it into slope intercept form and graph in slope intercept form. To me, I know what the strategy is to graph this line. So rather than spend all the time to put this in slope intercept form, I'm just going to graph it in this format. And this is called point slope form. So point slope form, this term right here is called y1 and x1, and that forms a point on the line, and m is the slope of the line. So instead of knowing the y-intercept, you find the starting point of the line somewhere else. So see how this says x plus 2? That really means x minus -2. So your starting point is at -2, comma, +3. See how this says in the original function, y minus y1 just gives me the point, right? So this is at -2, comma 3. This graph goes through. I'm going to show you how you could graph it in slope intercept form too. And what's the slope of this line? The slope of the line is 2. And so I can go 2 over 1 and make it into a fraction. So I can go up 2 over 1, down 2 over 1, and there is my line. So what if I wanted to do this in slope intercept form and show that they're the same? So you take y minus 3. I'm not going to write the parentheses. They're not doing anything right now. And I'm going to distribute this 2. So I'd have 2x plus 4, right? The distributive property right there. 2x plus 4. What would be my last step to solve for slope intercept form? I need to get y by itself. So I'm going to add 3 to the other side. Y equals 2x plus 7. Is that the same line that I just graphed over here? Right, aren't we currently at 5? So if I go up 2 over 1, don't I intersect right at 7? So isn't that the same line? So see how you get the same results either in point slope or slope intercept form. So you go for whichever one you like better. I just am used to reading this. This is the point 1, comma, -1, because this is really y minus -1 right here. 1, comma, -1 is the point on the line. So I graph the point that's on the line, and then I do the slope. This slope is -1 over 1. If you want to make it into a fraction, you can. So I go down 1 over 1, up 1 over 1. There's my negative slope. So you decide if you want to, go through the trouble of converting to slope intercept form. As long as your algebra skills are really strong, you don't want to make a mistake when you're transforming the equation. Just graph it in slope intercept form. One less thing for you to have to remember. If you like doing point slope form, then there you go. You got it either way. So the other form is called standard form. Again, you can just put it in slope intercept form if you like. I just want to show you the shortcut of doing standard form. The only benefit of standard form is finding the two intercepts and then drawing the line through the two intercepts. So if I plug in 0 for x, that term just went away. If I have 3y equals 12, what would y have to equal? So isn't one point on this line the point 0, 4? So I just found the y-intercept, didn't I? So I put 0 in for x. 2 times 0 is 0. So now I have the equation 3y equals 12. So dividing by 3, y would have to equal 4. So 0, 4 is one coordinate. The other coordinate that is easy to find in standard form is the x-intercept. Plugging in 0 for y, now I can cover up that term. Now I have 2x equals 12. So what would x have to equal? 6, right? So do you see how I just found 2 points? Oh, this doesn't quite fit on my graph. Any 2 points make a line. I don't know if I have some rulers. If you guys like to graph with rulers, there's rulers in that pink bin. You are welcome to anytime. I'm going to, for now, just to make it easier for this video, but there, I just graphed the line in standard form. If you want to go through the steps of transforming this into slope-intercept form, it wouldn't be that difficult. Subtract 2x to the other side. You don't have to do this part. I'm just proving to you, hey, these are the same. So I get 3y equals negative 2x plus 12, and my last step would be dividing by 3. So I'd get y equals negative 2/3 x plus 4. Oh, there's my 4. Didn't I go down 2 over 3, down 2 over 3? They should be the exact same line. So use whichever strategy you are more confident with. I'm very happy for you to just do slope-intercept form. My CP Algebra 2, I never teach them standard or point slope form. Too many things for them to remember. You guys have enough mathematical knowledge that if you want to use the actual strategies, go for it. If you prefer this form, that's fine, as long as you can graph the line correctly. Let's do the intercept way just one more time, just so you can see that one more time. If I plug in 0 for x, now that term is gone. So now I have negative 5y equals 10. What does y have to equal to make it true? Negative 5 times what will give me positive 10? Negative 2. So the y-intercept is at 0, negative 2. And the other intercept, when I plug in 0 for y this time, don't I just get x equals 10? So 10 comma 0, that's way over here, kind of way off my graph, but it works. So take that with a grain of salt. If you like those strategies, great. If you hate them, I take no offense. All right, so those are graphing. So then we talked about, during our linear pre-assessment, we talked about parallel and perpendicular lines. In case you need to, get that back in your brain again, parallel lines always have equal slopes. That's the parallel symbol for those of you that have taken geometry. Perpendicular lines have opposite reciprocal slopes. There's the perpendicular, like upside down capital T, for those of you who have taken geometry. Parallel, perpendicular.
Remembering the two intersecting lines, opposite angles thing. It's been a while since I've taken geometry.
Oh, you're remembering parallel lines with a transversal.
Yeah.
And identifying the pairs of angles that are corresponding, and yes, but yep. So that is actually the next unit in geometry. The first unit in geometry is just talking about just the pair of lines here without the transversal, but yeah. All right, so we are in algebra. So we're not doing a whole lot with the geometry. We're just identifying, are these lines parallel or are they perpendicular or neither? Perpendicular, they intersect at a right angle. You know that's 90 degrees, right? So I'm just looking at the slope. 6, negative 1/6. What's your conclusion? They are perpendicular, right? So I'm just going to draw the upside down T symbol so I don't have to write it out, but they are opposite. One is positive, one is negative, and they are a fraction that has been flipped of each other. This is 6 over 1 and 1 over 6. Part B, I cannot tell yet. Before I can determine this, I need to divide through by 2 so that my equation says y equals 3x minus 3. So now I can look at this 3 and this 3, and what's my conclusion? Parallel, right? Equal slopes are parallel. They will never intersect. And now this is in slope-intercept form. I see a 3 and a negative, or a 1/3. So what would be your conclusion? This is positive 3 and positive 1/3. So it's neither. One of them would have to be negative, right? So this one's neither. So taking two lines and just identifying that relationship as we move into systems of equations. All right, and then finding the domain and range graphically. So this is kind of what you did at the end of 112. I think that was the one we went over. Determine the domain and range. I think of it as closing a window. So horizontally, what domain exists? What x values? Can I have x be 8 over here? No, the only x value used is -5, right? So my domain is just -5. That's the only value in the domain. What about my range? Infinite. And so the way we write that is either all real numbers, or have you ever seen kind of the bold uppercase R symbol? So it's two vertical lines with kind of the uppercase R. That means all real numbers. So I can go forever. This is better than writing infinity. Infinity, if you're going to write infinity, you need to write negative infinity is less than y less than positive infinity, interval or inequality notation. You can't just say infinity. Okay, the next one. Quadratics, they actually go forever in either direction. So your domain this time is all real numbers. So side to side, that graph is going to push out forever, further and further and further and further. What about my range? So when I scan this graph, I never get down here, do I? So there's nothing down here on the graph. How can I represent my range? What y values am I allowing? Positive 1, right? Greater than or equal to positive 1. So you could get down to 1, but you can't go lower than that. So y is greater than or equal to 1. Oh, the other thing I like telling students, domain, comma, range, x, comma, y, they're both alphabetical order in case you forget which one goes with which.
I have a question.
Yeah.
The last one, the domain is -5 because it was hitting the -5, but why not for the 7 for the range? It's hitting 7.
Which one are you talking about, 7? B?
B, yeah. Like,
oh, because it's hitting 7 on the y-axis, but it's technically hitting 6 right there, and it's hitting 5 right there. So it's hitting the y value of 5 and 6, even if it's not touching the y-axis. Like this right here is about the point 1, 3. So I just used 3 as a y value, right? Do you see any points down here at like something common -2? My y value can never get to -2 down here. But the y value, if I just kind of push this over to the y-axis, I'm touching all those values all the way up. Does that make sense?
Yeah.
I see you're looking at the intercept. Okay, lines, they go forever in either direction and as far as they want up and down. So the domain and range for this is both all real numbers. And that's just something that'll come as we study linear functions, but linear is always going to be all real numbers. Quadratic, there's always going to stop somewhere. It's either going to be, parabola going up, a parabola going down. There's a vertex, and that stops your range from continuing forever. This is absolute value that we're going to see this year, and it goes forever side to side with the arrows, so that's going out forever. The range stops again, right? What's the lowest value that the graph gets to for y? -2. Y has to be greater than or equal to -2. And domain and range is hard, so if you don't quite understand it just yet, this is just an introduction. And then this is an exponential function. We're going to see this at the end of the year again, but it's going side to side forever. So even though it's getting steeper, it's also going in this to the right. So your domain is all real numbers. This might not be apparent on this graph. There's something called an asymptote down here, and it's not going to go below the asymptote. So it should just be y is greater than 0. We'll talk about that in a lot more depth at the end of the year. And then f, again, this is just a linear function. And so even without looking at it, I know that the domain and range are all real numbers. So see how you do on domain and range when you get to the guided practice, see what you can answer for those. So on the